Tutorial 2, question 1, part D. Construct the portfolio with minimum variance and write down its coefficient of variation. Okay, so we're looking for some weights in stock A and stock B, which minimizes the portfolio risk. There's a standard equation for this, and the great news is it's in the formula sheet in the exam, and it is as follows. The minimum weight for the weight for stock A given the minimum variance portfolio is the variance of B, take away the covariance of the returns on A and B, all divided by the variance on A, take away 2 times the covariance of returns on A and B, plus the variance on stock B. Okay, this is standard formula, and I should say at this point, I've highlighted this on the formula sheet. I would expect everyone on a second year financial maths course to be able to prove this. Okay, so you should be able to prove that. Okay, so we're going to use it. So we find that the weighting for stock A given the minimum variance portfolio, drop the numbers in from the previous calculations. Okay, I've done put the variances together. That's those. Take off 2 times the covariance. And we find that the amount invested in stock A is, well, it turns out to be more than 100%, 1.2248. So the amount invested in stock B is a negative number, 0.2248. Okay, and the negative here just means we should short stock B. So short selling, this means that we would sell the stock to some third party which we do not own, with the hope that the expectation that the share price would drop, and later on we could buy the stock for much cheaper than what we sold it for, and the profit on the difference. Okay, so we got these weights. So the expected return on this minimum variance portfolio is a standard equation. It's the weight of stock A, the return on A, the weight on stock B, the return on B, and if we drop those in, we get, let's see, we would get, okay, that goes into the calculator. By my calculation, 12.4264%. Okay, so notice the negative here. This shows that this is the interest we need to pay to the person we sold the share to. They're entitled to interest. We've sold it to them, so we hand that over. And in the first term, that's actually what we collect. Okay, so it turns out that there's some difference involved, and the expected return is about 12.4%. Okay, similarly for the variance. Okay, standard equation. I'll write it out. This is your standard equation. Okay, this is just number crunching. Drop all the values in. They'll appear on the page somewhere above. Straight into the calculator, you'll get around 94.281. So taking the square root, the standard deviation is approximately 9.7098%. 2 decimal places would have been fine, just a little bit extra. Okay, so there you go. We have the expected return in the minimum variance portfolio. And we have the risk. This is the standard deviation. For this minimum variance portfolio. And the final part of the question asked us to calculate the coefficient of variation. Well, this is the risk per unit of expected return. Simple calculation. Drop the numbers in. And we get approximately 0.7814. So this is the amount of risk required per unit of expected return. So 1% of expected return carries 0.78% of risk. Okay, and that completes this part of the question D.